Dr. Lutzmary, Associate Professor in the Department of Computer Science and Engineering at Rohini College of Engineering and Technology. The subject code is CS8088, and the subject I'm going to deal with is wireless network and sensor network. So the objective of today's topic I'm going to take is to understand the MAC protocols of a wireless sensor network, medium access control protocol of wireless sensor networks, MAC protocols and low duty cycles protocols, and wake-up concepts in wireless sensor network. So first of all, you have to have a basic idea of what is wireless sensor network. A wireless sensor network consists of spatially distributed autonomous devices. So using sensors to cooperatively monitor physical or environmental conditions such as temperature, sound, pressure, etc. A collection of sensing devices communicate wirelessly, even though wireless sensors has limited. So sensors have its own disadvantages. What are the disadvantages? They have limited resources, memory resources, limited computing power and bandwidth and energy. So these resources has to be made effectively. It should not be depleted, or it should not be underutilized or overutilized with a small physical size. It can be embedded in physical environment. Self-organizing multi-hop networks can have the sensors. So what is MAC access control? What is MAC? So MAC stands for media access control. A MAC layer protocol is a protocol that controls access to the physical transmission medium on a LAN. It tries to ensure that no two nodes are interfering with each other transmission. That is, there should not be any collision, and this is the situation where so they as far as the MAC layer is concerned, you consider in the diagram you have seen you have above the physical layer you have the MAC layer. MAC layer deals with CSMA bar, CD, token ring, token bus. So many protocols will be there. So the data link layer is divided into two layers: logical link layer and MAC layer. So the MAC layer protocols will operate on MAC layer. So power consumption, the sensor network have its own limitations. So power consumption constraints for nodes using batteries or energy harvesting, its ability to cope with node failures. It should have the self-configuring capability. The mobility of the nodes will be more. The heterogeneity of the nodes, the node type will be varying. So it may not be homogeneous always. Scalability to large scale of deployment, ability to withstand harsh environmental conditions, ease of use, then cross-link design. So initially you have to know what is an Ethernet operation, then only we can able to understand what are the MAC layer protocols will do. So Ethernet, so obviously it's an token bus. So A is sending the data to node D. So it transmit packets seen by all the station on the LAN because it's doing the broadcast, whether the B is willing to receive it or not. So A will send a message to B, C and D, even though the intended receiver or the destination is D. So address mismatch, the packet discarded. The address of C will be receiving the message, but the C is not the intended receiver, so the packet will be discarded. So address matches, the packet is crossed from A to D. So what are the situation we can have the collisions? So Ethernet data transmission for A occurs, and the C is also transmitting A, B is also transmitting. There will be a transmission for C, D will be sending. So C is also transmitting, then there will be a so Ethernet transmission. How the Ethernet transmission takes place in a network? A transmit packet, and you have to assemble the packet. Whether differing is on. If no on means you have to compute and wait and back off time. So you have to wait endlessly and until the transmission is over. So if not differing is not there, you have to start the transmission. Then you have to have collision detect. So whether there is a collision, yes, you have to send the jam signal. You have to increment attempts. If too many attempts are there, then excessive collision errors. If not, compute and wait back of time. You have to repeat or loop the procedure. Then transmission, if the collision is not there, you have to done the transmission. A is also sending, C is also sending. So collision avoidance with request to send and clear to send, RTS and CTS. So look into the diagram. A and C wants to send to B. A send ready to say request to send a message to B. B sends clear to send to A, but it's overheard by C, and C waits for duration of A's transmission. So overview of the MAC protocols. Initially we have contention based protocol, MACAW, and request to send, clear to send data with an acknowledgement. So the fast error recovery at the link layer. So IEEE 802.11 distributed coordination function largely based on MACAW. MAC collision avoidance is called the CSMA bar CA. So collision carrier sends multiple access with the collision space, IFS. So intermediate access when medium is free greater than differential interframe sequence, interframe space. So it's used by acknowledgement, CTS, a poll response. In short, PASS is used by the point coordinator in issuing polls. So it's used by ordinary asynchronous transmission that is distributed. The distributed coordination function in ad hoc mode. How it works. So virtual and physical carrier sense. So network allocation vector and duration field. So these are the things that has to be taken into consideration. Binary exponential backoff. Then ready to send, clear to send the data with an acknowledgement. For unicast packets, you have to broadcast a packet or directly send to the carrier sense. So random backoff, the busy medium. So pick a slot when it's uniform. 0, you will be having a contention window. The contention window you have to wait for the time. The busy medium is there. You have to check whether there is a contention or not. Listen up to the slot, chosen slot. Transmit if necessary. Transmit if necessary. Nobody else has started transmission. So wait if somebody else has started transmission. So example, a collision A and B happens to choose slot 4. Then both listen and hear nothing. So both transmit simultaneously. So node A and B will be checking that there is a busy medium. And after that they will be having the same thing happens to B also, A and B. So collision occurs greater than 2 nodes, first non-vacant slot. The contention window will be same for both the node A and B. It will transmit. Then slot 4. So both will transmit. Then there will be a collision. Both transmit simultaneously. There will be a collision. So high contention causes collision in CSMA. So we will be having a plot, the number of nodes versus the number of successful transmission. So number of nodes will be 100. So number of probability of successful transmission is linearly uniform over 32 slots. After that it will be exponential decay. Unacceptable collision rate above 15 transmitting sensor. Uniform virtual carrier fills up the timing relationship. The source will have the distributed interframe space, then ready to send. The destination will have SIF, source interframe space, then clear to send. Then you can have the source interframe space. Then the data will be transmitted. After that you will be having a time. So NAV will be having network allocation vector RTS. Then NAV CTS, clear to send acknowledgement. Distributed interframe space, there will be a contention window. It has to wait for the backoff after the deferred access because somebody is accessing. MACA protocol, contention based protocol. CSMA is a carrier sense multiple access. Ethernet CSMA by CD is not enough for wireless. So collision at a receiver cannot detect at the sender. A to B, the hidden terminal. A is hidden from C or the C is CS. Low duty protocols and wait. So introduction consumption, 4 modes of radio transceiver: transmitting, receiving, listening, and sleeping. The first three modes is also called as active or wake. So what are the first three modes? Transmitting, receiving, and listening. The power consumption are the 4 modes of mica modes: 52.55, 59.1, 59.1, and 1.278 millivolts. So what causes energy waste? So collisions, control packet overhead, and overhearing unnecessary traffic, long idle time. So these are the causes, because the sensor node will have less energy, so the energy consumption should be lesser. It shouldn't be wasted due to collision or control packet overhead or overhearing unnecessary traffic, long idle. So idle listening can be solved by sleep or wake up protocol. So when the duty cycle or the active period of the radio is reduced to 1%, the power consumption of the sensor node can be reduced by a factor of 50. So collision can be solved by ready to send or clear to send CSMA VASI up to 36% improvement. Overhearing can be solved by RTS and CTS with NAV, network allocation vector. However, the overhead of CTS, RTS and the CTS is relatively large when used with wireless sensor network. So where the wireless sensor packets are usually very small. In mica mode, the maximum data packet size is 41 bytes and the size of the ready to send and clear send packet is 18 bytes. CSMA, carrier sense multiple access with the collision avoidance. So it's a carrier sense multiple access. It's not suitable for wireless. We have BMAC, ready to send. It will transmit and receive the channel sampling for checking the channel activity. Source will be sending, then after that it has to wait for the T interval, then it can have the preamble, then the data will be transmitted. The channel sampling for checking channel activity, whether the channel or the carrier is busy or not, busy or idle. See, to avoid the collision. So drawback is overhearing, bad performance for heavy. It's not suitable for heavy traffic at all. So a long transmission delay. So why is MAC? So its drawbacks is maintain neighbors time offset, transmission latency is increased. The sender will be, after arriving, it has to wait for a random period of time, because the receiver is having T cycle. So it will begin to transmit. Then the transmitted the receiver will be active, then idle, after that it will be active. When the packet arrives, then you have to wait for this time, then the preamble will be there, then you have to send the data that time. So this receiver is also busy, then the sender has to have the acknowledgement for the data sent to the receiver, then it has to wait for the T cycle time. PMAC, pattern MAC. So PMAC divides time axis into frames, each of which consists of two parts: the pattern repeat part, PETF, pattern repeat part, and pattern exchange part. Both part contains many slots. So during the pattern exchange part, node advertise the intended sleep or wake pattern, so which represents one slot by one bit. So O for sleeping mode and 1 for active mode, and can be dynamically adjusted based on the traffic conditions. And during the pattern repeat part, a node wakes up according to the advertised pattern. Then A node also wakes up at time slot T. If one of the neighbor has advertised to be awake at the time slot and it has data for sending the node. So pattern exchange will be having two parts: pattern repeat part and pattern exchange part. Each and everything will have its own, it has many slots. So protocol classification: preamble based BMAC, WISE-MAC, and slot based PMAC, ZMAC, and H based MAC. Duty cycle synchronization based SMAC, TMAC, and UMAC. SMAC, coordinated sleeping. Frame schedule maintenance, choosing a schedule, listen to the medium for at least in the sleep mode. So nothing heard, choose a schedule, broadcast a synchronized packet. So following a schedule, receives a schedule before choosing and announcing, follows the schedule, rebroadcasts a synchronized packet. So adapting multiple schedules, receives a schedule after choosing or analyzing. So follow both the schedules, suffer SMA. I have to have more than one schedule. So since sensor network is having very less memory, so more energy and the power is will also be saving itself. It needs some power. So the battery power or the energy will be wasted. A node only rebroadcast synchronization for the first schedule. So neighbor discovery, chance of failing to discover an existing neighbor. So the corrected synchronization packet, collision, interference, new sensor in the border of the two schedules discover only the first schedule if both the schedules should not overlap. Periodically listen for the complete SP. So frequency. So if a sensor has no neighbors, SMAC experimental values SP 10 seconds, neighbor node discovery period 2 minutes in at least one neighbor. So maintaining synchronization, clock drifts not a major concern. Then no need to mitigate long-term drifts. Schedule updating synchronization packet. Listen is split into two parts. For instance, synchronization and RTS and CTS. Only RTS and CTS ready to send and clear to send is established data sent in sleep interval. So it is shown diagrammatically. Listen. So for CTS, this is for RTS for synchronization to the. So maintaining synchronization is also important. So drawbacks of SMAC, active or the listen interval, it's long enough to handle the highest expected load. If message rate is slower, energy is still wasted in ideal listening. So the SMAC fixed duty cycle is not optimal. So possible questions are: list of the MAC protocols of wireless sensor networks. Explain about low duty cycle protocols for sensor networks. Thanks for listening.